Today we're going to be talking about the sodium-potassium pump. The pump itself establishes the resting membrane potential. It's also a primary active transporter, meaning it needs energy to work, which is in the form of ATP. Go.
Now let's take a look at the sodium and potassium ions themselves. Outside the cell, there is a high concentration of sodium ions, and they want to move from the areas of high concentration to low concentration. On the other hand, there's a higher concentration of potassium ions inside the cell. This time, the potassium ions want to move with the concentration gradient outside of the cell.
Let's move back to the pump. The pump is an active transporter, meaning that it's going to push sodium out against its concentration gradient and bring potassium in. To do this, we're going to need some energy, and that's going to be in the source of ATP. ATP has 3 phosphates, and it's going to give up one of those to the pump.
When no phosphate is bound to the pump, that means the pump is open towards the inside of the cell. At this time, 3 sodium ions can bind to the pump. When inorganic phosphate binds to the pump, there is a conformational change in the pump that releases 3 sodium ions to the extracellular matrix. Once those 3 sodium ions leave the pump, then 2 potassium ions can bind.
When inorganic phosphate unbinds, the pump is going to change back to its original shape, opening back up to the inside of the cell and releasing our potassium. Let's conclude with the visual.
Thanks so much for watching. Make sure you like and subscribe.